In this video, we'll explore how to extract survey data for your proposed route using online maps and some handy software. This process is crucial for creating an accurate and feasible road design in Civil 3D. Open Google Earth Pro and locate your project area. Go to Tools, then select Options. In this dialog, ensure to set Show Lat Long as Universal Transverse Marketer and meters as the units of measurements if you intend to design in metric standards. Hit Apply, then OK to update the settings. To obtain survey points, we'll utilize the Add Path command located here in the toolbar to define the proposed road alignment. Give the path a name from here. I will type Road Centerline. Start defining your proposed road centerline by clicking points along the desired route. Designing a road requires to consider the existing terrain, ensuring proper drainage and maintaining safety standards. I will use this data to design a dual carriageway corridor in Civil 3D 2025 and will also discuss on the geometric vertical profile design. Click on a point to start defining the path, then proceed to create the other points while following the road centerline. I will click here to define my next point, then go to Measurement tab and set the length to meters. You can try to adjust the points with specific length offsets for an enhanced point data like say 20 meters interval. I can click on the next point, then try to set the length to or close to 40 meters. With that in mind, I will proceed to add other points along this center line of the road. By extracting survey data, we get elevation points which define the height of the ground along your proposed route and also the centerline alignment which defines the path your road will take. This free software allows us to visualize the terrain and define points for our proposed road. I will zoom in the map, then add points along the road centerline of my proposed route. As you can see, we can proceed to add other points along the proposed route for the road design. In this video, we'll be using Google Earth, Global Mapper, Excel and Civil 3D to take you through the entire workflow of the point data creation. This process requires internet connection to search for the place and later in Global Mapper, as you will see. Each of these points created represents where the coordinates will be taken. I will continue to add the points randomly up to somewhere here. While still in the command, I can zoom to this other road to define an intersection to a single carriageway, as you can see. Don't mind on the created path line because we'll only be extracting the point data in Global Mapper as a text file. I will proceed to add points for this other proposed design road centerline alignment by clicking along the centerline of the road. You can add additional points for key locations like curves or intersections according to your design route. By following this method, you can easily obtain the coordinates and elevation of each point defined in your proposed project design. With this, I have finished to design my proposed routes for the two corridors using the Add Path tool with name as Road Centerline. I will press OK to proceed. Next, we can define other points to the left and right sides of the centerline by using the Add Path option. I will type ground data as the path name. Then, while still in the command, start placing points around your centerline that will be used to define the working surface in Civil 3D. You can add your points according to your project area view. I will fast forward this part as I add more points for the ground data as it will be in an actual road project. While adding the ground data points, avoid placing points over buildings and try to have your points taken within or at the road reserve limits for professionalism. I have taken many points along the proposed route that will help me identify the general terrain of the project area. After finishing to define this alignment, I will repeat the same process of adding points at both sides of this other alignment too. Accurate survey data is crucial for designing a functional and cost-effective road. It provides information about the existing topography along the proposed route, and this data helps engineers to determine the vertical profile, drainage design, calculate earthwork quantities, and to identify potential challenges during construction. Each dot or point will represent an actual point with X and Y coordinates and its elevation. I will continue to add points up to where my proposed road ends. Press OK to continue after you have defined your ground data points. With the two paths defined, we can save them as KMZ file, then load the data in Global Mapper software to extract the elevation details. Go to Places, right-click on Road Centerline, then select Save Place As and click Save to continue. I will right-click on Ground Data, select Save Place As, then click Save with type as KMZ format. We can switch to Global Mapper to extract the surface elevation data. In Global Mapper, I will start by selecting Open Data Files, then pick Road Centerline and click on Open. This software lets us access online elevation data and create a digital elevation model to extract elevation points for our chosen route. Click on Configure to modify the default settings. In Projection tab, I will drop the list, then scroll down or jump by typing U, then select UTM. The software automatically sets the correct zone and datum for the project location. You can view the zone from the bottom right region in Google Earth. Back in Global Mapper, you can hit Apply then OK after setting the projection to UTM. Click on the world icon to connect to a data source. I will select SRTM Worldwide Elevation Data as the data source that will generate the point elevations. Select a data source, then hit Connect with an internet connection to download the elevation data. The data will be downloaded according to the screen view extent. You can change the order of the layers from the control center to view the imported path. With this, we can proceed to extract elevation points along our defined path as a text file for the road center line. To do so, go to File, then Export, then select Export Vector Leader Format. In this dialog, I will drop here, then scroll down and select XYZ Simple ASC text file. This format will extract the survey points data. I will click OK to proceed with the XYZ text file format selected. In the export options, set coordinate separator as comma and feature as blank line. Choose X as first in the coordinate format. I will leave the other selected options as you can see, then press OK to proceed. Save the file in a working folder. I will type road centerline, then leave the type as text and click on Save. We now have the northing, easting and elevations for the road centerline points. Right-click on road centerline from the control center, then click on Close to unload it from the project. Select Open Data File, then pick on the ground data file and click Open. We can proceed directly to export the ground data text file without adjusting the project. Go to File, Export, then select Export Vector Leader Format. Select the XYZ format, then click Open. Press OK again to export with the previous options defined earlier. I will type ground data, then click Save. We can now open the point data files from the save location to see how the program has exported the information. If I open the ground data file, you can see all points have data for the X, Y, and elevation at end for each and every point or dot defined from Google Earth. This is how you can seamlessly extract survey data from online maps starting from Google Earth to Global Mapper. We can now switch to Excel to modify the point file by first opening on a blank workbook. I will open the ground data text file exported earlier. Select the first digit here by clicking in front once, then drag downwards by clicking and dragging. Press and hold Ctrl, then Shift and End button to highlight up to the last point in the list. Right-click, then select Copy with all point data selected. Go to Excel, then drop at Paste. Click once, then select Keep Text Only. The values have been pasted in the spreadsheet as you can see. To separate the values to individual cells, go to Data tab and select Text to Columns command. Set to delimited as defined from Global Mapper software text file, then click on Next. I will select comma delimited. The preview of the data can be viewed from below here. In this last tab, I will leave the column data as general, then hit Finish. All data have been placed in separate cells as defined. Go to the A column to add a new column in front for the point number information. Right-click on column A, then select Insert to add a new data column. We can utilize this column with the point number data as required in Civil 3D point format. Type 1 in the first cell, then 2 in the next cell. Select both cells, then double-click on the add sign to autofill the numbering to the last lower cell. We now have the point number information for our point data file as seen. We have extracted 272 points with the X and Y coordinates and elevation using online map data. You can define the points description from this last column. I will type P1 and P2, then use the autofill command to have the points descriptions for the ground data. Double-click here to autofill the description column to the lowest row. This is the format that is very ideal for usage in Civil 3D as P, E, N, Z, D. I will scroll down in the list to add the road centerline data. Open the road centerline text file from the save location. Highlight from the first point digit, then click and hold Ctrl, then Shift and the N key to select all data, then use Ctrl C to copy the values. Drop and paste to the second cell selected to paste the values. The software remembers the text to column command. Highlight on the last two number cells above, then use the autofill option to continue the numbering. We can use another description format for the road centerline points. I will type CL1 and CL2, then autofill to the last data row for the road centerline points. This is how you can extract and edit the point data file to fit the Civil 3D point data format from Google Earth to Global Mapper, then Excel. We can now save the formatted spreadsheet as a comma-separated values file. Browse to your desired working folder, then give the file a name. I will type survey data, then change save as type to CSV, delimited, then hit save. With this, we can finish today's video by switching to Civil 3D, then import the point file. Civil 3D allows you to utilize the imported points for various road design tasks. I will start by creating a new drawing using the metric template. Please note that these levels are not accurate. They are only used for preliminary designs or proposals. You may need to extract the data remotely for the design proposal, then later take the actual project levels using the survey equipment so as to set out the final road levels. Drop at the civil icon, go to Drawing Utilities, then select Drawing Settings. You may need to adjust your project zone to the correct zone before importing the points. The default setting is at no datum, no projection. Drop the zone list, then pick your region zone or select UTM datum to have your project points well georeferenced to match Google Earth's location. I will use UTM WGS84 datum, then drop at the available coordinate system and select the zone where my project lies. I will scroll to zone 37 south as earlier defined in the bottom right corner from Google Earth. Choose the correct zone where your project is located from the list. With the project zone and coordinate system well defined in Civil 3D, we can press apply, then OK to proceed to import the points. In Civil 3D, we can import points by going to Toolspace Palette, Prospector tab, then right-click on points and select Create. Points can also be created from the Home tab. Select Points, then Points Creation Tools. In the Create Points dialog, you can use this last icon to import the points. Select on the green add sign to import the points. Then browse to where you saved the survey data file. Select it, then click Open. For the point format, we can select PENZD as we defined while creating the point data file. P represents the point number, E for easting, N northing, Z elevation, and D for description. We can leave the Add Points to Point group unchecked for now. Then proceed by clicking on OK to view our points in Civil 3D. I will close the Create Points dialog. To view the points, I will type ZE for zoom extents, then press Enter. And there we have it. By following these steps, you can easily extract point data from online maps and import them to Civil 3D for design proposals or use for practice. We now have point data with elevation and coordinates for each point defined while creating the path in Google Earth. You can edit the points display style from Toolspace Palette. Select on points to view all points below the Toolspace Palette. Expand point group, then select all points, right-click, then select Properties. The point style and point label styles can be edited from this dialog. If I set the point label style to description only, The points will have the descriptions and the point markers for all points as seen. We can discuss in the next video how to create this road using the online data to design a dual carriageway to a single lane road with an intersection where they meet using design manuals for a comprehensive understanding. We'll be discussing each major steps in creating the road by using our extracted data. While online data is convenient, consider using a survey crew for highly critical projects to ensure utmost accuracy. In case you are watching this channel for the first time, please take a second or two, click that subscribe button so that when we produce a video like this, YouTube will automatically inform you. I want to thank all the channel subscribers for the continued support because without the support, this channel cannot be where it is. Feel free to leave a comment below for any questions or suggestions. That's it for this video. Until next time, keep designing.